Assalamu alaikum wa rahmatullahi wa barakatuhu. In discontinuous flyback SMPS designing series, in our last videos we discussed how to calculate DC rail and how to calculate inductance, primary inductance, and how to calculate primary current and RMS current in primary. So today we will discuss the transformer consideration for discontinuous flyback. If we see very closely, here we have a transformer, primary and secondary. But if we see, this transformer is totally different from our transformer action. Why? If we see here, first we have to give a slight look here. It is our F operative. When Q1 is on, it will cause to flow current in the primary. But the secondary is out of phase, 180 degree out of phase. So if this end is positive, in that case this end will negative, because this transistor will allow switching. It will start to build magnetic field. So due to opposite winding, here is positive, so this end will negative. In that case, this diode is reverse bias. When this diode is reverse bias, so our transformer will in this condition. When T on, secondary is not visible in T on. Why? Diode is reverse bias. So it will not allow to flow any current in the secondary, because the path here is break. What will happen? It will flow current in primary. So due to inductive reactance, the IP primary current will start linearly. When the T1 is off, T on is off, this time off, at that time the magnetic field will collapse. When it will collapse, it will cause to induce voltage in secondary, but this time the voltage will positive. Now in T off period, this transistor is off. So primary is not visible because it is not making any load on the input voltage, VDC. Here is VDC. So in off period, the transistor is off. So this magnetic field will collapse. So in this way, it will cause to induce voltage in secondary. When the Q1 was on, there was no induction in secondary. When Q1 is off, the voltage will induce in secondary. When Q1 is off, from here to here, it stored energy. The amount of energy will be L primary, I primary. So this is amount of energy. This energy will be stored in primary, so it will cause to induce voltage in secondary. So when the maximum energy will transferred during T off period, and we will allow a dead time, TD, T on, T off, TD. This dead time is allowed before starting the next switching cycle. A time allocated in discontinuous flyback before the next cycle is starting here. So Q1 will start from this point, and IP primary current will start to build again. At that time secondary have no voltage because diode is reverse bias. But when the current was flowing, it charged the capacitor, and our load will take current in the off period from this capacitor. sorry, here in T on, the load will take voltage, take current from this capacitor. This our output capacitor will fulfill the requirements of load during T on, and while this operation it will store energy. When it will off, then it will induce voltage in secondary. Q1 is off, voltage transferred to secondary, charge stored in the capacitor. The same, when it will replenish the charge, the capacitor will full. That time it will go also in switching mode. This will off and capacitor will drive the load. So it will keep pumping to the capacitor. So this is the function of this flyback transformer. So now we have to consider, when Q1 is on, this transformer will behave as an inductor because due to the transformer winding. So energy is half Li square, primary inductor, and it will follow the amount of charge transfer in the secondary will follow primary to secondary turn ratio. How? Suppose from here in the primary we flow 1 ampere current and we have 100 turns, for example. So we will take 100 ampere turns, 100 ampere turns, and this is ratio. And if we have this primary, now come to secondary. If we have 10 turn in secondary and we have the amount will transfer to the secondary is 100 ampere turn, so that means 100 divided by 10 ampere current we can get in the secondary. 100 ampere turn energy stored here, so we will transfer this ratio. This is ratio. For example, we have 100 turns, then we have 100 divided by 100, 1 ampere. If we have 1 turn, that means we will take 100 ampere. So it will follow the turn ratio rule. Now we have to consider, we are going to design a choke, a inductor with extra winding. So in primary number of primary turns will depend on the voltage and for time T on, how much time we will allow to switch the transistor, and we will need Bmax and core area, core cross section area. The second thing, we have to consider the voltage stress on this transistor, because in flyback mode if we have equal turns, 100 turns are here, 100 are here, so the stress on the transistor will double. We will calculate in our next videos. Now in calculation of transformer, the basic item, that is core selection. To consider core selection, we have to know all the cores are calculated in push-pull topology, that is bidirectional. But our this transformer, we can say it is transformer, it is unipolar magnet. For unipolar magnet, when we go to typical power handling chart for the ferrite cores, there are different cores at different power watts at different frequency levels. So come to the footnote. Wattage value shown above are push-pull converter design. D-rate by factor 3 or 4 for flyback. If you want to design a transformer for flyback operation, we have to D-rate by 3 or 4. For example, I want to design a transformer. For example, I select this core 810 watt. This core PQ4040 will provide power 810 watt in push-pull topology. But if I want to use it in flyback, so divide it by 3 or 4. For example, we divide it by 4, so it will give us around 200 watt. It will handle the power at 200 watts. If we divide by 3 or 4, 260 watt, 200 to 260 watt, it will handle the power. So to use, derate by a factor of 3 or 4 for flyback. These videos are to design a discontinuous mode power supply. So we have to select a core that will provide us power at 200 kilohertz. In our next video, we will see a different ways to select the core. We will analyze how to use this power handling chart, how we can select a core using area product method, and how we can select a core using KG method, KG approach. I hope so this video is informative. Thanks for watching, and if you have any question, let me know in the comment box. Assalamu alaikum wa rahmatullahi wa barakatuh.